Hi, now we're going to show you control structures in Python, and I have the code from the book here with just slight modifications. Um, so the first code they show you is for a while loop, and this is one of the basic loops in Python. It works exactly the same as while loops in C++ and Java, but the syntax is different. And so this is an example of how all compound statements, statements that have a body of code, like ifs and loops and things like that work. The body is indented instead of using curly braces. So you should always use 4 spaces to indent. The way pycharm is set up is if you hit tab, it will insert 4 spaces for you. A lot of programming editors will allow you to set that up as a preference. It may not be the default like it is in pycharm, but so let's look at how it works. Before we start the loop, we're going to set a counter, which will be our loop control variable. Then we say while counter is less than or equal to 5. So the general syntax is you have while, and then you have a Boolean expression that results in true or false. The expression does not have to be in parentheses like you are required to do in C, C++, and Python. Now, in all compound statements, it uses the colon to indicate that we're about to start the body of the loop. So there's 2 things that mark the body, the colon and the indent. So everything indented at this level will be the body of the while loop, and as soon as you go back to the previous indent level, it knows that's not part of the loop. So this loop will count from 1 until the counter is 5 and print hello, and it will increment the counter inside. I'm also pointing out here, and I don't think the book does it, but you could replace this statement here with this counter plus equals 1, and you may remember that from your C++ or Java class is a statement to do a shortcut for adding something to counter. Python doesn't have the plus plus operator like in C++ and Java. Here's another example they have in the book. You can have a while and then you can have a Boolean expression that's more complex. So here they have 2 terms that result in true or false. And one of them is a flag, and they use the word not in front of it, and they use the and operator. So they're combining 2 true or false results with an and they'll keep doing the loop until either this is true or while this is true and this one is not true. So I set done to true here, so it will properly exit because the counter never changes. I use a pass statement. So this loop actually will stop because done is set to true initially. So it says and not done. This will become false, and that will cause the loop to not execute. I also have placed a pass statement. This is a special statement you can put anywhere you have a body of a compound statement or even a body of a method, and it's basically a placeholder for the body that says do nothing. If you try to do a loop and you leave out all the statements after the loop, it will be a syntax error. The next example is a for loop. So the for loop always works by for some item in something that iterates through a list of things. So item will assume each object that's in the list of things, and the body of the loop. So again, we have the colon, the mark that we're about to start the body. We indent in, so the body in this one consists of 1 statement. So it's going to item will be first it'll be 5, it's going to print 5, and then it's going to be 10, it's going to print 10, and so on. It'll print these values. You can also use range. You can use anything on the right side of the end that creates a sequence of values. So range creates a sequence of values. In fact, technically the thing on the right is what's called an iterator. It iterates through a range of values. And so it's going to print out 10 to 4 going -2. So it's going to count down 2 at a time, and it actually will stop before 4. And you'll remember 4 is always in a range. The second number is always just past where it stops. You can also nest structures. So here's a more complex example. We import math. We're going to use that later. Module math. It sets a list of words, and it makes an empty list we're going to fill in, which is empty. And then the outer loop will loop through each word. So a word will be cat the first time through the loop, and then it'll be dog through this loop, and then it'll be rabbit. The inner loop will then work on that word and have a loop through each letter of the string that it got here. So it'll loop through C, A, T in the inner loop. And when it's all done with CAT, it goes back to the outer loop and gets the next word. And what the inner loop does is just append each letter to letters. So what it does, you give this a list of words, and it's going to basically string all letters out individually as items. And you'll see when it prints it, it's a list of individual letters that are all these words. Here's an if-else. So it's also what you might expect from everything we covered so far. You say if, you have a Boolean expression, a colon. You have a body, which can be one or more statements. Then you go back out to your previous indent level and have an else with a colon. And then you have the body of the else, which can be one or more statements. Now here's a nested if statement. This is typically very messy to do because you have if, and you have what happens if it's if, and then you have else, and so this if else is the whole body of this else, and this if else is the whole body of this else, and so on. So each if is nested inside of an else. So it turns out this is a common structure to do when you have some value or something you're comparing and you're making a multi-way decision, is what we call it. You'll notice the last else is just else, and then you print F. So there's another way of doing this, and that's what it shows here. It's called the if, elif, else statement. So the elif stands for else if, so it stands for what you're doing here, but now you can put it all in a nice, much flatter structure. There's not as much indenting, and it's easier to read. You also have if with just a single branch. So if this is true, it does that. And this isn't in the book, but there's a special ternary expression. It's like the ternary operator in C++ and Java, which you probably have forgotten by now. But this is an expression, it's not a statement. And the syntax is you put some expression of true, if, some Boolean expression, else, some expression of false. So in this case we have absolute value of n if n is negative. So we're testing if n is negative. So that if n is negative, the result of this expression will be absolute value of n. So it's going to change it to positive. If this if is false, it's just going to return n as it is. So this expression will return either the value on the far left or the far right, depending on the Boolean expression in the middle. Now we're going to talk about a shortcut for creating lists because you do it so often, and they built some special way in Python to do that called list comprehension. And list comprehension allows you to use basically a loop, like a for loop, to create a list, and it has an optional if you can add that would filter your results. So here's your normal way of creating, say, a list of just the squares of 1 through 10. So we set up an empty list called square list. Then we say for x in range 1 to 11, so that's going to count from 1 to 10. And so x in here is going to be 1 to 10 as it goes through the loop. So every time through the loop, it's going to take 1 and multiply it by itself and append that to the list. And then it'll do 2 multiplied by itself, so that'll be the square of 2. So when this is done, you'll get the list of squares. But this is the same example as this, but using list comprehension. So you can see you can do it much simply. and it's actually a little more readable. So it says basically make a square list that equals start a list, make it the square of x for x in the range 1 to 11. And then if you want to only do the squares of the odd numbers, you can use something like this. So you have a square list odd equals start a list, do the square for x in range of 1 through 11, but only if x modulus 2 is not equal to 0. This is testing if it's odd. If this filter is not true, it doesn't add x to this list value. And then here's a special one. This is a list of no vowels, and it also changes everything to caps. And they have this example in the book. I just put an extra new line here. So when you run it, all these examples have separate outputs. So it has, inside the print, it has this expression from here to here, and that's the list comprehension. So what it says is for ch.upper, so this is an expression using this ch. So you're going to see the pattern here. You don't have to use the letter x for your for loops. So for ch in this word, so basically it's going to build a new list that's going to only create uppercase letters of ch for all the letters in this word, but only if the letter in this word is not in a list of vowels. So this will actually only take out the non-vowel letters here and make a list. So we run this, and you can see all the results here. I'll let you do that and examine everything. Now I made another file that's going to be available that shows you different examples of a lot of this, so you can look through this file. And it shows you some special things. Here's an example of how you would loop through a dictionary and get all the key and values. Here's a complex example at the end, which is actually looking at how you might implement a game that runs until the user types something special. So I have some other examples here, and read all the comments, which gives you kind of a background. So that's it on control structures.